Alright, so if you don't have right triangles, you use the law of sines. So the law of sines can be used on any triangles. It could be used on right triangles too.
This is new stuff now?
Yes, so this is new stuff. So the law of sines, it can be used with any triangle. So the law of sines is listed in your book as sine of alpha, but I'm going to change it to sine of A over A equals sine of B over B, which equals sine of C over C. And remember that I'm just going to draw a random triangle. A is always across from little a, B is always across from little b, and C is always across from little c. So,
I have a question. Does
yep.
it matter, like, as long as they're across from each other?
No, it doesn't matter as long as they're across from each other. So I'm going to show you guys an example of this. And it's going to say solve the triangle using the law of sines. Does anybody remember what solve the triangle means?
Yeah. Find all six trigonometric
Good.
functions.
Anthony is correct. Find all angles and all sides. Okay? So, we're going to use this triangle. Okay, so it's helpful if you draw the triangle out. So, the first thing I'm going to do is I'm going to say sine of A over A. So, sine of A over 6.5, or sine of 80 over 6.5 equals sine of B over 3.4. And I'm using B and 3.4 because they're across from each other, and now I can solve. So to solve, I multiply both sides by 3.4. And so I get sine of B equals, and you put 3.4 times sine of 80 divided by 6.5 in your calculator, and you get out 0.51513. But we're trying to solve for B. So just like we did before, you have to use the inverse sign. So B equals inverse sine of 0.51513.
Is it always done?
Yeah, because we're using a lot of signs.
Okay.
So yeah. And that would be 31.01. So for B, we can say B is 30. I like to list them to the side because it helps me stay organized. So I'm looking for B, big C, which is an angle, and little c, which is a length. So once I have two angles, how do I find the last angle? They should add up to what? All three angles of a triangle add up to 180. So C equals 180 minus 80 minus 31.01.
68.99.
And that's right, 68.99 degrees. We should have a little degree sign here.
And then you use the Pythagorean theorem.
You cannot use the Pythagorean theorem. You can only use the Pythagorean theorem with a right triangle. It's not a right triangle. So we can do the law of sines again though. So we can say sine of 80 over 6.5 equals sine of C now. So sine of 68.99 over little c. And I'll put 31.01 in here and 68.99. And then we can solve for C. So I like to cross multiply, so I have C sine of 80 equals 6.5 sine 68.99. And then what do you do to solve? What do you do to solve?
Take out the sign.
Well, you have to get rid of this, right? So divide by sine 80. And so C equals 6.5 times sine of 68.99 divided by sine of 80. And that gives you 6.16. So C is 6.16.